So in this video I'll be going over the discriminant. Now this topic is linked with quadratics, it's linked with simultaneous equations, and it's also linked with inequalities. So the discriminant. So a parabola can intercept the x-axis or intersect a line either twice, once, or not at all. And we can determine this by looking at the discriminant. Now the discriminant is taken from the quadratic formula, in which the key part to look at is the b squared minus 4ac. So to work out the discriminant, the first thing you need to do is make the quadratic equation equal to 0 and then pick out your a, b and c values of the coefficients of the x squared, x and the constant, substitute it into b squared minus 4ac and you will have your discriminant value. Now, if your discriminant value is greater than 0, then what that shows is that the quadratic curve has two distinct roots or two solutions. And basically what that means is that the quadratic curve will intercept the x-axis or the line at 2 points. So in this case, the blue line intercepts at minus 4 and 2. For the red line, it intercepts somewhere between about minus 0.8 and also about 2.8. When the discriminant is equal to 0, then we say that it's got one exact root or two equal roots. So depending on the wording, it means that. So what that basically means is that the line or the x-axis will touch or intercept the curve at one distinct point. So here the red line has one equal root at 2 and the blue line has one distinct root at 0. If your discriminant value is less than 0, then what this basically shows is that there's no solutions, which kind of makes sense if you relate it to the quadratic formula, because as b squared minus 4ac is inside the square root, one number you cannot square root is going to be a negative number. So if your discriminant value is a negative number, then there will be no solutions for that. And the last thing that we come across is sometimes an exam question or a textbook question could use the words of real roots, in which this could be either, the quadratic could either have one distinct root or two distinct roots. So it could be one of two options if they use the word real roots rather than classifying it with the word equal or two. So let's get started on some basic questions. So in this particular question we've been asked to find, with regards to the following quadratic equations, state whether they have two real roots, equal roots or no roots at all. So if we start with question A, the first thing you want to do is make a note of the coefficients of A, B and C. So with question A, I've got that A equals 1, B equals positive 11 and C equals minus 2. So now what I'm going to do is I'm going to substitute those values into my discriminant, which is b squared minus 4ac. So what I've got there is I'm going to end up with 11 squared minus 4. And I always tend to put brackets around the 4ac just to protect me from making any mistakes with regards to negatives. So times 1 times minus 2, which gives me 121, minus 8, which becomes 129. Now what's good practice at this particular point is stating the following statement. So as b squared minus 4ac is greater than 0, therefore it has two real roots. And it's always good and important for you to write down this statement just to prove what it comes through, because sometimes in a future question you might get asked to prove it's got two roots or show it's got two real roots. So it's always worth adding this extra statement rather than just showing what the discriminant value actually is. So moving on to B, let's see if I can do that in a different colour just to make it stand out a little bit. Let's go for blue. So again, we highlight what our A, B, C values are going to be. Let's go for this blue. So here I've got 1 again for A, minus 3 for B, positive 3 for C. So from here I've got B, so I've got A equals 1, B equals minus 3 and C equals positive 3. So again for B, substituting it into my discriminant formula, which is b squared minus 4ac. So I've got minus 3 squared minus bracket 4 times 1 times 3, in which here I've got 9 minus, and it's going to be 12, which equals minus 3. So therefore, as b squared minus 4ac is less than 0, it has no solutions. Then finally for C, and what I'm going to do is I'm just going to rub all of this out. And while I'm at it, I might as well rub that out too. In which, so for C, I'm going to follow the exact same process. As soon as I've picked a colour, come on, there we go. Let's go for orange. So for C, I've got A equals, now for C, as you can see, the key thing I almost forgot there is the first and ultimate rule is making sure it's equal to 0. So in this, you can see that it's not equal to 0. So what I need to do is write down the question, or the equation again rather, so that it is equal to 0. And now I can write down my ABC value. So A equals 9, B is going to equal positive 6, and C is going to equal 1. So for C, substituting it into the discriminant formula, I get 6 squared minus 4 times 9 times 1, which then leaves me with 36 minus 36, which equals 0. So as B squared minus 4AC is equal to 0, it has an equal root. Well, you could say it's got one solution, but equal root's probably more sort of mathematical terminology, and there you go. So in this particular question, it's like a reverse question, because what we need to do is we need to work out what part of the question is. So in this question it says that if a squared minus 8x plus 2 equals 0 has a repeated root, find the value of a. So the key thing we need to note here is that it's got a repeated root. So as it's got a repeated root, well, what does that mean? Well, that means that we need to change the colour. So this means that the discriminant is going to be equal to 0. So knowing that, and just turn back to the purple pen. So then returning from that, we know that we've got a, which equals a. We've got, don't know why I put that mark there, let's get rid of it. Nope. We've got that b equals minus 8, and we've got c equals 2, and we need to show that it equals 0. So what we've got is we've got minus 8 squared minus 4 times a times 2, and that's all got to equal 0. So what we've got is we've got 64 minus 8a equals 0, taking the 8a over to the other side, in which we've got 64 equals 8a, so a equals 8, and there's the answer for that one. Now in this question, it's not related to a single, it's related to a graph, and in this particular case we've got a straight line and we've got an equation of a parabola. Now in this, the key thing to note in this is recognizing what is a tangent. So if x minus 3 is going to be a tangent to that curve, then what that means is that it's only going to have one intersection point. So if y equals minus 3 is a tangent to the curve, then b squared minus 4ac has got to be equal to 0. So first thing we need to do is substitute the equation into the quadratic. So in terms of the steps, what we're going to do is we sub the line into the quadratic, and then what we're then going to do is simplify and make equal to 0, and then what we're then going to do for our final step is show that b squared minus 4ac is equal to 0. Now the other thing to bear in mind with this question is that it does involve two questions. The first one is what we've done here. The next part is then finding out the the coordinates for the point of contact. So recognizing with regards to this one here, what we've got is we've got x minus 3 equals x squared minus 5x plus 6, as they're both equal to y. So simply taking all of this to that side, we get x squared minus 6x plus 9 equals 0. And then looking at the discriminants, we've got A equals 1, B equals -6, and C equals 9. So then substituting into the discriminant, we get -6 squared minus 4 times 1 times 9, which gives us 36 minus 36, which equals 0. So as B squared minus 4AC is equal to 0, Y equals -3 is a tangent. So the next thing we then need to do is then find those coordinates. Now, where a lot of students tend to get confused on this one is they get the equations all muddled up. So for this, what we need to do is it now turns into a simultaneous equation question. So for this part of the question, when you're looking at the intersection points, is it turns into simultaneous equations. And just have to excuse my handwriting. So first thing we need to do is substitute the equations in, which we've actually done. So what I'm going to do is I'm going to kidnap this line here, and I've got x squared minus 6x plus 9 equals 0. It does factorize to give me minus, does it factorize? -3 minus 3, and so what I'm going to do is then factorize this. So we've got x minus 3 equals 0. So as we've got repeated root, x can equal 3. And then what we then need to do is find the respective y ordinate. So when x equals 3, y equals x minus 3. So we've got y equals 0. So the coordinate of the tangent is going to equal 3, 0. And there you go. And there's just an example of some common questions that is linked to the discriminants.